Hi, 8th graders. So we've been working on rotations. We're going to take a little break from rotations because I'm out today, and we're going to start dilations. So as a quick review here, we've gone through reflections. Reflections are when you flip or look at the mirror image of an object, the size and the shape are preserved, so you have congruent shapes still, but the lettering changes or flips around as well. Translations are when you're sliding or moving the object, the size and the shape is also preserved, creating congruent shapes, but the orientation is also preserved. The lettering is okay. Rotations, which we've been working on, are when you're turning or spinning or pivoting the shape. Again, the size and the shape is preserved, making them congruent images, and the lettering, the orientation of the lettering stays the same. Today we're going to talk about dilations, is when you're changing the size of the shape. So either the shape is enlarged, the shape's enlarged or made larger, or the shape is reduced, which is made smaller. So to kind of show you what I mean by that, I have two hearts down at the bottom here, and we'll call this guy the pre-image, the original shape. An enlargement, a dilation that makes the shape bigger would be if I take and made this guy larger. It's proportional to the original, it's just larger. Or if I go back and start with the pre-image, the original shape, and I take this one and I make it smaller, proportionally smaller, so it's the same as this guy, it's just smaller, that's the reduction in there. So when I'm asking you if the size is preserved, the size is not preserved. It gets larger or smaller. The shape does stay the same shape. The heart, the pre-image, the heart stayed a heart whether I made it larger or smaller. So the shape is still the shape, but it's a different size. Because the size is either enlarged, made bigger, or reduced and made smaller, they're not congruent. They are just similar. We'll get more into the idea of similar, but similar objects are the same shape but different sizes, larger or smaller. The lettering is going to also be preserved. So I'm just making it bigger or smaller. If I'm not flipping it at all, the lettering, the orientation will remain the same. So if we go into an example on the coordinate grid of a dilation. So number one in your notes, and remember you can pause this and try this on your own. You can rewind to rewatch something or pause it to fill in the notes and kind of make sense before you move on to the next question. So number one here says figure DEF, which is a triangle, is shown on the coordinate plane below. The figure is dilated from the origin, so where it's dilated from the origin by a scale factor of r equals 3. R stands for scale factor, so in this case the scale factor was 3, which means is 3 times the size of the original. We'll talk about more how I knew that it's going to be an enlargement, just looking at the scale factor number. So it says identify the coordinates of the dilated figure d prime, e prime, f prime, and then draw and label figure d prime, e prime, f prime on the coordinate plane. All right, so the first thing I'm going to do is I'm going to name the coordinates of the point. So D is at, let's see, I go over to -2 up to 2. So D is at -2, comma 2. So the dilation is 3 times the size because the scale factor was r. So what I'm going to do to get D prime is I'm going to take the x coordinate and multiply it by the scale factor, comma, take the y coordinate and also multiply it by the scale factor. So D prime will be at -2 times 3 and 2 times 3. So 3 times the size will move D to D prime of -6, comma 6. So I'm going to make a point right there in the coordinate plane, and I'm going to label that D prime. So it got larger further away from the origin because it was around the origin. So this guy spread out from the origin, this guy's going bigger. Then if I take after D, I'll extend the page a little bit here. The original point E is to the right 4, so 4, comma, up to 2, 4, 2. So E prime is going to be me taking, I'll take a little extra space out, me taking 4, the x coordinate, times the scale factor of 3, and the y coordinate of 2, and multiplying it by 3. So basically I'm taking each coordinate and multiplying it by the scale factor, which will make E prime 4 times 3 is 12, 2 times 3 is 6. So now if I graph E prime, will be over 12 for x and up to 6 for y. So here is E prime. And then if I connect those, guys, let's pick a color here. Okay, from E to G, a straight line there as best I can do with my pieces. And then I have to do the same thing for F. F, let's pick another color. The coordinates of F, the original point, was to the right 3 and down 1. So F is at 3, -1. So then F prime is going to be take each of these coordinates and multiply them by the scale factor, which in this case is 3. So 3 times 3, comma, -1 times 3, which means that F prime is at 9, comma, -3. So from the origin, I'm going to go to the right for +9 and down 1, 2, 3. And here is F prime. So if I connect those points, I'll probably be better off just drawing the lines myself. You'll see that D prime, E prime, F prime is larger than the original piece because it's 3 times the size. So the shape is the same shape, it's just now bigger or enlarged because the dilation had a scale factor of 3 times the size. Now what I want to point out before we move on is the length of line DE, the original piece. So if I go from D to E, that's 1, 2, 3, 4, 5, 6 units long. And now I want to look at line D prime, E prime, the new piece. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units long. And you're going to notice something between that 6 and 18. Remember our scale factor, we wanted it to be 3 times the size. So each coordinate, x, y coordinate, was multiplied by 3. Look at these units. The original length to the new length, it also is being multiplied by 3, that scale factor. And that's not just a coincidence, it's going to happen for each of them. All right, if we look at number 2, let's see if I can adjust the size here a little bit so you can see it on the screen better. All right, number 2 says you have quadrilateral, which means a 4-sided figure. Quadrilateral GHIJ is shown on the coordinate plane below. The figure is dilated from the origin, so I'm dilating it around the origin, so it's either going to get larger or smaller with a scale factor of 1/3. So again, before it was R was 3, now it's R is 1/3. So it's 1/3 the size. All right, so 1/3 the size is what that scale factor of R equals 1/3 means. So we're going to identify the coordinates of the dilated quadrilateral G prime, H prime, I prime, J prime, and then draw and label that new quadrilateral on the coordinate plane. So name the coordinates and then draw and label it on the graph grid. All right, so this time I have 4 points. And again, just like the last one, I'm going to take each XY coordinate of the original quadrilateral and multiply it by the R, the scale factor of 1/3. So if G starts at -12, 9, my pen's going a little crazy here. Let's see if I can, -12, 9. So if I take, for G prime, it would be -12 times 1/3, comma, 9 times 1/3. So remember with fractions, just put them over 1. So this would be -12 over 3. So -12 divided by 3. So G prime is -12 thirds, comma, 9 thirds, which would make, bear with my pen here, G prime, -12 divided by 3 is -4, and 9 divided by 3 is 3. So G prime is going to be at -4, 1, 2, 3. So here is G prime. Notice I got closer to the origin. That point of dilation is around the origin. I got closer to it. And you're going to notice R is 1/3, and it got closer. And in the last one, R was 3, and it got further away. So now if I do the same thing, but this time we use H. H is at 3, 3. So if H was at 3, 3, H prime is to take the x-coordinate of 3 and multiply it by 1/3. Then take the y-coordinate, which is also 3, and multiply it by 1/3. So again, I'm just going to fix that 3 because my pen is being a little touchy today. So h prime is at 3 times 1 over 1 times 3. So 3 over 3, comma, 3 times 1 over 1 times 3, so also 3 over 3. So h prime is going to be at 1 comma 1. So from the origin 1 1, here is h prime. Again, it got closer to the origin. Our scale factor was 1/3, so it got closer to the origin. And then I'm going to pause here and quickly fill. I'm going to pause and I'm going to fill in the other two. So I'd like you to pause right now and see if you can get I prime and J prime's coordinates, and then unpause the video so that you can compare your results to mine. All right, so hopefully you pause the video and you can compare. So I was at 6, 0. So if I take 6 and multiply it by 1/3, I get 2. And 0 times 1/3 is still 0. So I, guess switch my color back here, I is at 2, 0. So I moved, again, closer to the origin. And then J, switch my color here, J, I took -3, the x value, times 1/3, and I got -3. And -3 times 1/3 and got -1. So J prime is at -3, -1. So here's J prime. And then if I go and connect those 4 points, G to H, H to I to J, and J back to G, you're going to notice that it's the same quadrilateral, it just got smaller. So we want to talk about the scale factor, the size of the pieces. The scale factor, I go to the next page. The scale factor, there's 3 different types of scale factors. Remember, R stands for the scale factor. So R is scale factor. When R is greater than 1, so if R is, right, our first one, R is 3, R is 12, R is 2.4, 2 and 4/10. Those are all R values greater than 1. I can throw a fraction in there. R equals 7/5, right? It's an improper fraction. That's the enlargement piece. It's an enlargement, and they are R times bigger. The line segments that made the piece will be R times bigger. Now the angle measurement, so this was the segment sizes. So I'm going to go back real quick. Each of these pieces are the same piece. They're just 1/3 the size for the dilation because our scale factor was smaller. Over here, this one we did count. This one got 3 times bigger for the line segment. Now if I look at the size of the angles, just wondering if I can. The angle measurements, if you'll notice if I slide this, the angle measurements are staying exactly the same. Now I drew that one out so it's not as good, but you're going to see the angle measurements don't change. So let me go back here. Again, the angle measurements, exactly the same on all 4 angles of this quadrilateral. All the angles are exactly the same size, but the line segments changed. So when scale factor is greater than 1, the segments are going to get larger, R times larger. So if I had 3, they're 3 times bigger. If I had 12, they'd be 12 times bigger. If I had 7/5 for the scale factor, it's 7/5 times bigger. The angle measurements, they don't change though. They're going to remain the same. And that happened for when it got larger and even when it got smaller. So the second one says when R is less than 1. So switch my color. So that could be R equals 1/2. R equals 25/100. All of these make the line segments smaller, or that's the reduction. So they will be R times smaller. And again, just like I just showed you, the angle measurements didn't change. The angle stayed the same measurement. The segments changed. So again, the angle the angles will remain the same whether you have an enlargement or a reduction. The angle stayed the same. The size of the segments that make the shape will be larger or smaller depending on if r is greater than 1 or less than 1. Now when r equals 1, if you remember when we had a dilation, we took the x and y coordinates of each point and multiply it by the scale factor. Well, if I multiply by 1, it doesn't change. That anything times 1 is that number. So in this case, the only one here would be r equals 1. The segments stay the same, so then the angles stay the same as well. But when I have an enlargement or a reduction, the angles stay the same. It's the segments that change their size. So this is kind of an important thing. So if I look at the next example here on page 3, it says triangle KLM has coordinates of k, -20, 35, L of 0, -40, and M, 50, 15. The figure is dilated from the origin by a scale factor of 6/5. So the scale factor, or the r value, is 6/5. So based on that, without graphing anything, will it be an enlargement or a reduction? And if you wrote enlargement, you are correct. Because this is an r value that's greater than 1, it's an enlargement. So it's asking us to identify the coordinates of the dilated triangle. So we're going to start with each of the original points, multiply each xy coordinate by 6/5 to get our new one. So here's k prime. Oh, it is if I take -20 and multiply it by 6/5, comma, take the 35 and multiply that by 6/5. So I'm going to put these over 1. So two options at this point. I can take and multiply the numerators, multiply the denominators, and then divide. But if I know cross-canceling, it's going to save you a lot of time. 5 will go into 20 4 times, and it's a -20, so -4. -4 times 6, that's -24. And then the same thing here. I can take 35 times 6 and divide that by 1 times 5, but I know that 5 will go into 35 7 times, and 7 times 6 is 42. So k prime is at -24, 42. It got larger, right? The values got further away from the origin. Now if I take L prime, let's see, starts with L of 0, multiply that by the scale factor of 6/5, and the y value was -40 times 6/5. And again, I'm going to encourage you to pause the video right now so that you can try the L prime and M prime and get their coordinates on your own, and then unpause the video to check back in. Alright, so hopefully you paused the video. So for L prime, I took L's coordinates and multiplied the x by 6/5 and the y by 6/5, but I used some cross-canceling to simplify to get 0, -48. So L still has the 0 for the x coordinate, but you'll notice the y coordinate got further away, right? The scale factor is greater than 1. It's an enlargement. It should be getting further away. And same thing with M prime. M was at 50, 15, so I took 50 times 6/5, got 60, and I took 15 times 6/5, and I got 18. So again, it's getting further away from that original point, so you have an enlargement there. And the last one we're going to look at today is figure NOP has coordinates of N 4, 8, O -18, 3, and P of 5, 9. The figure is dilated from the origin, so it's a dilation, and our job is to figure out if this is 0.5, is that an enlargement or a reduction? So it's this time, since R is less than 1, we're going to say that it's a reduction. The original is going to get smaller. I'm sorry, the image after the dilation will get smaller and closer to the point of origin of the origin. So identifying the coordinates of N prime, O prime, and P prime. So R is 5/10, which is the same as 1/2. So if R equals 0.5, 0.5 equals 1/2. And I'm going to do that because this will make my calculations a little bit easier. So N prime's coordinates will be to take N's coordinates of 4 for x, multiply it by 1/2, comma, the y coordinate of 8 and multiply it by 1/2. And again, you could just take your calculator, 4 times 0.5, 8 times 0.5 to get your two coordinates. That is allowed as well. If I kind of just do some mental math, because it's not that tough there, 2 goes into 4 twice. That will give N prime at 2, comma, this 2 will go into 8 4 times. So 2, 4 will be N prime's coordinates. So I can find them without the graph grid. Then I have O prime's coordinates will be the -18 from O's coordinates, multiply that by a half, comma, the y value was 3 times 1/2. And I can multiply my fractions, but I can, let's see, 2 will go into negative 18, negative 9 times. Negative 9 times 1 is negative 9. This is one that some of you might want to grab your calculator for. 2 doesn't go into 3 evenly, meaning a whole number of times, but half of 3 I can also say is 1.5. And if you don't trust me on that, you can take 3 times 0.5 on your calculator to get that guy for the O's coordinates. So if I had to graph that, I'm going to have to go to the left 9 from the origin, and then up 1 and then a half more. So it might not be right on the line. And then our last one here, switch my color, we have P prime will be to take P's coordinates of 5 and multiply it by a half, and Y's coordinate of 9 and multiply it by a half. So again, I know that 5 and 9 are odd numbers, so half of them is going to involve decimals. So you can take 5 times 1/2 or 5 times 0.5 on the calculator. Half of 5 is 2.5, and half of 9 is 4.5. So P prime has some decimals in its coordinates, which is allowed, a little harder to graph, but you can do that. So that is all for today. Make sure you've completed all assignments with the substitute before you leave today, and I will be back tomorrow and we'll continue with dilations.